Hello everybody. I'm Enzo. I'm creator of Colyseus, and today I'm going to talk about making multiplayer games with Colyseus, Node.js, and TypeScript. Very excited to be here. So the topics of this talk are the state of networking on the web, alternative servers, how Colyseus works and its internal systems, some client-side techniques that you can apply even outside the scope of Colyseus, and a few multiplayer games built with Colyseus. So the state of networking on the web, right now we have, for bidirectional connections, we have mostly WebSockets and WebRTC available. Web Transport hopefully is going to come in the future. WebSockets is TCP only and is available since 2011. WebRTC has been fully standardized only in the last year and is fairly complicated and it involves a lot of other protocols, and it does support reliable and unreliable connections. Web Transport hopefully is going to replace WebSocket in the future. Nobody knows when. And it's very exciting. It does support reliable and unreliable delivery and has experimental support already on Chrome since January this year. General advice for networking outside of the web is that TCP is not ideal for games and UDP is. It's hard to disagree with this, but unfortunately, the web only has TCP as of now. Hopefully, Web Transport is going to change that in the future. And many successful games have been made in the past using TCP. And WebSockets is what we got, and there's a lot of successful games made on top of WebSockets. Okay, with that out of the way, let's talk about alternative servers. So in an alternative approach, you wouldn't trust the client, so the client can say, for example, where he is, or the client, it should never dictate information. The server should always be able to validate and tell the truth about the state of the game. So this is not very authoritative. It might be fine if you're okay with this. So this wouldn't be feasible on a multiplayer competitive game. So an alternative to this is give less information for the server. Let's say I'm pointing at a certain angle and moving forward. So the server has the current position, and the server is going to determine what's the next one, and not the client. So this is authoritative. The responsibilities of the server is to hold the game logic, game state, validate client inputs, and exchange messages with the clients and also the state. The responsibilities of the client is basically to be a visual representation of what's in the server and send inputs and actions for the server. So what Colyseus brings to the table, it is a Node.js framework. It's built only with WebSockets. So there's only WebSocket as a transport layer so far on Colyseus. It makes players into rooms and has a built-in room synchronization and message system. And it has the build blocks and the architecture, so you can scale this to many servers and have many servers handle multiple rooms. And yeah, as you can see, rooms is a very basic block from Colyseus, and this is how a room definition looks like. And it has its lifecycle methods, such as onCreate to set up the match, onJoin when some player joins the room, on leave to clear this player from the room state, and that the other clients can react to this change. And on this pose, when this room has been destroyed on the server, so yeah, if you have like a shared global state or something on the database, this is a good place to clear global things that this room has possibly created. And in order for the clients to join this room, you need to expose for this for the matchmaker. Yeah, you see that there's no actual room being created at this point. Rooms are only created when the client requests to join or create them. So on this example, it's the client requesting to join a game room and providing some information about himself, such as the name. For the matchmaking request, this is how the flow looks like. The client makes an HTTP request to ask for a seat reservation. The server is going to query for possible rooms that already exist. And if it doesn't exist, it tries to create one and returns the room ID and session ID, which is the session reservation. And after he got the session reservation, it tries to actually connect through WebSockets. And this is how the flow looks like from the server side perspective. First, it tries to validate the user during on-auth. This is totally custom and based on your own requirements. And if that succeeds, it tries to call onJoin. At any point, you could throw an error here, and the client will hit the catch block here. I mean, it could, yes, you could throw an error from the server, and here it will go in the client. Yeah, if no error has happened during this process, the connection is established, and right, and after the connection is established, then the first thing is that the client receives the full room state, so the client can already build a visual representation that that room has on the server, and start exchanging messages and more state patches and more messages, and yeah, then it's regular. Regular WebSocket and bidirectional stuff, right? The onMessage API is fairly simple. So this is how you listen and send messages between client and server. The server can send a message to a particular client based on the client reference. And the server can also broadcast messages to every client inside this room. So there is no built-in way for that the server sends the broadcast for every client on every room. If you need to do that, you need to implement that yourself. So the room state. The room state is based on mutable structures. So you can't really use any immutable structure as you would in front-end frameworks. And the mutations that you perform on those structures are synchronized automatically at every 50 milliseconds by default. And those mutations are on way. So you should only mutate data, state data on the server, so they are broadcasted back to the clients. You should never mutate the state in the client itself. Right. The structure we use for the state are called Colyseus schema. It is strongly typed. It supports incremental serialization, has the lowest throughput we could possibly implement, and it provides a client-side callback API. So I'll explain a bit about this in a few. And it's very inspired by other serialization libraries such as protocol buffers, flat buffers, and others. Right, so on this example, it's imagine a board game. So you have a map of players here, and the player has like a position, let's say a position on the map or on the board. And on the room code, you would initially create the state. So you set state during creation. And whenever a player joins this room, we assign to the map of players a new player based on the session ID of that client. So yeah, session ID is like the unique identifier for this client on this room. And yeah, and whenever the client sends like a move message, it gets the player reference and increments his position. As you can see, this is not very authoritative, as any player could send this at any moment and it would increment his position. So ideally, there must have some sort of validation for like, is this player in his current turn, does he has any uh, pending valid moves left? Like some checks like this. Um, yeah, so on the client side, uh, every client should listen to like adds and removals from this player structure. So these are the callbacks you would register on the client to prepare the visual representation. And yeah, this is listening to the position attribute change. A cool thing of using TypeScript is that if you do provide, this is optional by the way, if you do provide the type reference for the room state here, you would have auto-completion for all the properties and everything inside the state during development. Yeah, so what's the difference between messages and room state? Messages are ephemeral and they're not persisted anywhere. So whenever you send a message, only the current connected clients are going to receive it. And the state, on the other hand, is persistent. If you set something on the state and a new client joins, that new client is going to receive that data. Right. So on multiplayer games, lag is inevitable, and we should, as developers, should embrace it and just try to alleviate the perceived lag from from the current player. Yeah. So take this, like you have the client at position 1010, then he sends the action to move forward. And the server here, he gets that he's at 11, 10. But the client could have moved immediately here, and he's going to receive back this data from the server only a couple of milliseconds later. This is called the round trip time. Yeah, this is half round trip time. And you could use this value to perform some techniques on the client side to try to at least give the player an immediate response. So this example from half the opposite implements client-side prediction which he basically process players' input immediately on the client side. So whenever you press the keys to move, your player moves immediately. On the server, it enqueues the player actions and process the queue at every server tick. Yeah, you can have a look at the source code there. It is applicable to if you want to use this approach on outside of Colyseus as well. There's this really nice presentation from GDC explaining Overwatch gameplay and netcode. I highly recommend you check this. They explain the whole client-side prediction that they did there. And yeah, they also say some techniques for dropped packets, and we can't really apply any of this on WebSockets because there's no drop packet on a reliable connection. Only when we do have on web transport, we could apply such techniques. Yeah, so linear interpolation is very simple and can have good results. On Masmora, this game I've made, I use in linear interpolation everywhere. So you see that this is a tiled-based game, and um, the player moves like across the tiles with linear interpolation. So locked time step is very important for a physics-based game. It's also called as fixed tick rate, and having a deterministic physics is important because then you could have like many clients and the server if you need to simulating the physics with different FPS and having the same output. So limitations, server limitations, like how many, yeah, I hate this question. How many CCU can a server have? I mean, you can find some material on the internet that people manage to have 1 million WebSocket connections on a single server, but that's not very realistic. You could achieve that mostly with idle connections, not exchanging any messages, and that's not realistic at all. What I could achieve is on a cheap server, a WebSocket, a WebSocket server running a card/board game that is very slow on the pace of messaging. The server could handle 3K concurrent connections, but I wouldn't recommend having a single room with those many connections. 50 to 100 would be the ideal. And if you need more connections than that, you can have more rooms across other servers to handle this load. So yeah, then scaling comes into play. And scalability, the rooms live in memory in Colyseus. So rooms are stateful and games are generally stateful. So you really need to you can't use stateless approaches to yeah for games I don't understand how people always recommend being stateless when scaling things. And there's a persistence layer that allows any node to matchmake. To recap, this is how the seat reservation works on a single server. And when you have multiple servers, the seat reservation request would come to the load balancer and it will be forwarded to any of the active servers. Then any of the active servers would return the reservation, and then having this information, we can make the WebSocket request directly to the server that that room is living. So how many CPU can Colyseus handle? It depends. I don't know. It depends on your game. And you have CPU and memory limits, and everybody does, no matter if you're using Colyseus or not. So for Colyseus itself, I would recommend avoiding having a very large room state, which would increase the throughput of your rooms, and optimize your game loop to use the least amount of CPU cycles as possible. So yeah, I'm running out of time here already. So the tools, additional tooling we have is this monitor for development. It can be really useful. A load test for creating like small bots and test how far your servers can go with automated load testing. And yeah, so some cool games made with Colyseus. This was the very first game, very first well-made game with Colyseus by Tiny Dobbins. It's still available here. I believe this has been released in 2015. This is made from the community. It's called the Open Source IO Shooter. It can be found here on this link. Raft Wars, me and Tiny Dobbins made with a default engine. It's also a web game available here. School Break made by Tobias. It's also available to play here. And Kirka.io is the first player shooter I've seen that is using Colyseus, and it's very fun. And finally, Night's Edge by Lightfox Games. This is a Unity game, also available to download. And that's it. I hope you learned something. I'm waiting for your questions. Thank you so much.
So let's first take a look at the poll results for the question we asked at the beginning.
No, none of them.
We have. Well, yeah, I was actually interested about that. If that means people haven't made multiplayer games, or if they have and they just didn't use one of these options. Because I don't know what else you would be using, unless.
I was expecting like playing WebSockets to be the leader. It's actually. Sorry, go ahead.
Oh, that's how I interpret this. Like for people who made, I think, multiplayer games, it sounds like WebSockets are the top option, which makes sense because at least for me, like I've only made stuff in like Socket.io, which I interpret as basically just a layer of this framework around WebSockets.
Oh yeah, Socket.io should have been on this list as well. Yeah,
okay.
Probably.
That's why I was wondering if it wasn't. No, that's cool. And then there's a bunch of people using sorry, can you pronounce it? Colyseus. Is that how you pronounce it?
Colyseus. Yes, correct.
Colyseus, yes. Thank you. There's a bunch of people using that too. And what is Nakama? I haven't heard of that one.
Which one? Sorry.
Nakama.
It's they're written in Go, so that I think that's why not many people have heard of it. They are kind of similar, but they're written in Go. Yeah.
Cool. Good to know. Cool. I think we can jump to some of the audience questions now. So I think the first one we have is a more general question about web games. The question says, how different is the process between placing elements on a screen via HTML, CSS, etc., versus making one of these HTML5 browser games? And there's a second part to it. How would you describe the current ecosystem of tools and frameworks for building these types of browser games, particularly those like old retro / flash game like games?
It depends a lot. I'm not sure how to start to answer this question, but you can have like a regular game without using canvas at all. If you manage to, it can be more tricky, but it's possible. But yeah, for any type of you usually would use a Canvas or a Canvas 2D or WebGL to actually render things in real time. Yeah, what is the second portion of the question?
It's just how would you describe the current ecosystem of tools and frameworks, and maybe like another way to phrase this is like what maybe frameworks do you use or would you recommend?
Yeah, there are plenty of options currently. Actually, there's we had a talk recently about Little JS. It's one tool that you could use. I think from what I saw on that talk, it's mostly for very small outputs. So you would use that. That could possibly be used for those ad games that you see. I'm not really sure. I'm just assuming as it's small. But I personally like using Pixie.js, and I think tomorrow we're going to have a talk from Play Canvas. Play Canvas is also really great for 3D. And we had a talk about Babylon. So yeah, there's like so many options. It's hard to count actually.
Yeah, I also kind of second the Play Canvas because I like it because it also, if you're used to, I guess, having like an editor and things where you can place things, that I think that helps a lot. Play Canvas has them. Great. We have another question about just generally about client-side prediction and how it works. Can you talk just a little bit about that?
Yeah, that can be complicated. I very recently I've wrote a client side just for simple movements. So for example, it depends also how is your input. For example, if you are using your keyboard as an input, you usually would send a message at every single frame, which can sound a bit ridiculous, but that's how it works. I mean, how is one approach to this? And then it's I can't really explain properly. I miss my words, but it's basically you're trying to execute on the client side before the server really sends the message where the thing actually is on the server.
So like maybe one way to think about it, because I think you mentioned this a little bit in your talk, where you have a player and the angle of the player, and the player wants to move forward. And instead of waiting for the server to say you're going to be in this position, you can assume that you're going to move forward, and then when you get it back, you can sync that. Makes sense.
And what can be a bit tricky about this is that let's say you move your client forward, but you have another. That's why it's really complicated to have player-to-player collision on multiplayer games. For example, you see so many multiplayer games that don't have player-to-player collision because it's tricky, it's complicated. Like Brawl Stars, like most point and click, like Dota. I think League of Legends also don't have it. I'm not sure. But like you have your local simulation, and like which client should the server trust? Like it's easy to get misaligned. Yeah.
Cool. No, that makes sense. Does sound much more complicated. But obviously it comes with the trade-off of it'll look better if you can pull that off, because then you'll have seemingly less lag. I think we have one more question. Someone's asking about Unity. If they're using Unity, is it possible to use Colyseus? Is there a plugin or a way to use it with like a Unity WebGL export?
Yeah, it is. There's a client available for Unity. And yeah, there's one game that was made with Unity. It's available on mobile. It's really cool.
Awesome. And if they wanted to find that, would it be on like the GitHub or the web page, the Unity?
Yeah, plugin? There's Colyseus.io, and from the GitHub repository, you can find pretty much all the links, all the information.
Awesome. Well, I think that's all the questions we have. Thank you so much, and it was great having you here.
Cool. Thanks so much for having me.